So here is another parametric equation which generates a little three-leafed clover, if you like, or a flower with three leaves. So in order to generate this, I've put it first of all in Desmos. So this is the online graphical calculator, and you can see the actual function which I've used here. So it's maybe a little bit small here, but it says 120 sine 3t times cos t and 120 sine 3t times sine t. Okay, so this is the x coordinate and this is the y coordinate, and I've picked the values from 0 to 2 pi in stages of 0.1. Okay, so we end up with 64 little dots. So these are the little dots that we're expecting to find whenever we actually work through the code. So now let's have a little look and see the code which I've generated. Okay, so this is the code here. I can make it a little bit bigger. Okay, that's a bit bigger now. And it's relatively straightforward and similar to previous code. So we've starting off with a value of theta, which is 0 degrees, 0 radians, and we're first doing a check and seeing whether the value has hit 6.28. If it has, then it just jumps to the end of the program and that's it finished. If it hasn't, then it's going to run through this loop 64 times. So when it runs through the loop, the first part here generates the 120 times sine 3 of theta, which we can call r. Okay, now the next part takes that r and multiplies it by cos theta, and then the next part takes that value for r and multiplies it by the sine theta, and then we simply plot off the 2 points, which are going to be the points r0 and r1. So r0 is the x, r1 is the y, and then R2 is the colour, and I've just left the colour at white. And then we do the increment value, so we increment in values of 0.1 radians, and then we go back to the beginning again. So that's the code. Let's have a look at the final outcome from our CPU. So here's the final outcome here, and you can see that it's actually finished. I'll stop it here, simulate, and I'll stop it. So there we have it there. Now it would be good if I could get both of them together on the one screen kind of thing. I'll make sure I don't actually close it down. So let's have a look and see if I can get this here. So that's it there, and I'll make that a little bit bigger. Okay, so you can actually compare and see the individual values, and the individual values for this actually match up with individual values here. Okay, so if you look at these two here, we've got 1, 2 there, and we've got the 1, 2 here, and then we've got the 1 at either side here and here, and you can see we've got the 1 at the either side here and here as well. Okay, so we can continue, and you can note the 2 that are together at the centre here, and we've got 2 together here at the centre. So every single point here that we've got in the 64 points matches with every single point here. So just for us to kind of get things into perspective, we're able to generate parametric equations. Okay, so this is the parametric equation rendered in the online graphical calculator Desmos. Okay, so you can see here if we pop the grid in, there's a grid there. Okay, and you've got an x-axis and a y-axis, and all the points will match up. Okay, so if we go from there, and then we can go for that onto our actual CPU, and we've run through the code. We've generated the points in terms of floating point numbers, and then we have taken an approximation in terms of an integer value and plotted them on the screen. So it's exactly the same, almost exactly the same as what we get in the online graphical calculator Desmos. So I think that'll be the final bit of code that I will do. I've messed about with that for about an hour or so today. It took about a couple of hours for it to run and to render all the 64 points, but I'm quite pleased with it. I think it looked quite good, and it just shows off the power of the CPU and the floating point library. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.